Hello everyone, welcome to lesson 3 on Newton's laws. Today we will go over the November 2020 past paper. Let's get straight to it. Question 2.1. Define the term normal force. Once again, I think only appropriate to ask the president himself what he thinks. The perpendicular force exerted by a surface on an object in contact with the surface. I'm not going to spend too much time on this. Definitions are important. Learn them. Moving on to question 2.2. Draw a labeled free body diagram of the 20 kilogram block. First things first, I will draw the surface, which you do not have to draw. You only have to draw from this point, the block. So that is what I'll do. I will draw in the 20 kilogram block. Once again, looking over to the right hand side, we will see our 3 vertical forces as well as 4 horizontal forces. These are the only forces you will ever have to know for matric physics. Learn them, use them as a checklist. First things first, looking at the vertical forces. Is FG there? Yes. So what do? We draw it in. And I will label it FG. Notice the 90 degrees to the surface. Okay, the next vertical force we have is the normal force. So I will draw that in and label it FN, and it is at 90 degrees. Then moving on to our horizontal forces. What do we have? We have the force of tension in the right direction. So we will draw that in with the arrow and label it, the force of tension. Then we have the force applied, but it is at an angle. So what are we going to do? We will draw the force applied at the angle. I will label that. And lastly, we have the force of friction. So the question is friction going in this direction or in this direction? Okay, and we get that information from the question paper. So you will read that the box is moving at a constant speed to the right hand side. So the box is moving to the right hand side. And what do we know about friction? It always opposes the force of motion. So if the box is moving in that direction to the right, friction would be moving there. Okay, if the box was moving up, friction would be moving down. If the box is moving to the left, friction will be moving to the right. It always opposes. So finally, we will go and draw that in. The force of friction. Now, what do we have? 1, 2, 3, 4, 5 forces. So therefore, 5 marks. Nice and simple. Moving on to question 2.3. Calculate the combined mass M of the 2 blocks. Okay, so I hope that you guys have read the question paper, even though I haven't paused it or told you to, but you should always read the question. I'm just not going to read it from top to bottom. But anyways, moving on. What do we do first? So always we are going to write down our F net is equal to MA, and I'm going to divide the page in 2. To be honest with you, I don't even know how to do this question. I'm just going to follow the formula that I always follow, and I'm sure it will work out. Okay, so and lastly, we're going to say that to the right is equal to positive. This is very important, and I'll show you now why again. Okay, so luckily let's label this. So we will label this block 20 kilograms. Okay, and now what are we going to do? We're going to move from this F net, okay, and we're going to break it down into its subcomponents. Luckily, we have the free body diagram already. So we said it's positive to the right, okay, so the force of tension would be positive. Minus, what else do we have? The force of friction minus the force applied, okay? There's obviously no FG parallel, so we do not include it. But we already answered that in the free body. Okay, is now equal to MA. Do we have the force of tension? No, we do not. Do we have the force of friction? Yes, we do. They've given it to us. Do we have the force applied? Yes, we do, but we still need to work out the actual answer. Okay, do we have mass? Yes, we do. And do we have acceleration? Yes, we do. We'll get to that now. So, first things first, let's solve for FA. We know that FA would equal 35 cos 40, which equals to FA is equal to 26.81 newtons. Now we're going to sub in as much as we can and get an equation. So let's do exactly that. We have the force of tension minus the force of friction, which they gave to us in the question paper at 5 newtons, minus 26.81 newtons, okay, is equal to the mass of 20. And do we have acceleration? Yes, we do. They've given it to us as 0. Okay, so we know that A is equal to 0 because it is at a constant. Oh, yeah, that's right. Constant speed. Okay, that is why we know A is equal to 0. So now, if I just simply go and rearrange this equation, okay, what do I get? I get that Ft is equal to what? Ft is equal to 31.81 newtons. Okay, and I'm going to label this as equation 1. Moving on to the right-hand side. To label this block PQ, or you can label it block M, but I like PQ. What are we going to do? We're going to once again break F net down into its subcomponents. There is no free body diagram, but we can think about it. What forces do you guys see? Okay, remember to use the vertical and horizontal forces that I've labeled out as a checklist. What do we see? We see positive Fg and down, right and down is equal to positive. What else do we have? We have the force of friction. No, the force of tension is equal to MA. For some clarity of mind, we can go through the other forces. There's no force of friction. Why? Because they've said it in the question paper. There's no force applied. Why? Because we can see whilst looking at the image. So just using the checklist, we get the answer. Okay, now subbing in. Can we work out Fg, or do we have it? No, but we can work it out. Do we have the force of tension? No. Do we have the mass? No. Do we have acceleration? Yes, we do. So we know that A is equal to 0. Okay, we also know that Fg is equal to what? Is equal to mass times gravity. Now, subbing in. So what are we going to do? We're simply going to plug and play into that formula. So Fg is now equal to mg minus the force of tension is equal to what? Well, it's equal to 0 because why? A is equal to 0. So now if we sub A, and I'm going to say this is equation 2. Moving on, I will now say sub 1 into 2. In other words, I'll take this force of tension and plug it in right there, okay, and I'll get a value of M eventually. So I'm going to do exactly that. M times 9.8, we've just subbed in for gravity, minus the force of tension, which we get from equation 1 at 31.81, is equal to 0. So we can use our solver calculator, or we could just do some more maths. So we have M is equal to 31.81 over 9.8, and therefore we have M is equal to 3.25 kilograms. Boom. Moving on to question 2.4. At a certain stage of the motion, block Q breaks off and falls down. How will each of the following be affected when this happens? Okay, so first things first, I'll go and I'll just write down my F net is equal to MA. Okay, and just based off the question, we know that when block Q falls off, what will happen? The mass will decrease. So the mass is decreasing. This is important. You need to understand that. Okay? So by them saying block Q falls off, you should be able to say the mass decreases. That is what they're looking for. How will each of the following be affected when this happens? The tension in the string. Okay, so I'm just going to give you the answer. The answer is decrease. And why does it decrease? So let's think about it, okay? For example, well, I always like to think of real life scenarios. Okay, if I've got a wall, or a roof, should I say, and I've got a string. Okay, and this string has a person attached to it. And he's hanging from the ceiling. You and I both know, okay, that if we add more people, should give them smiley faces. If we add more people, the string will what? The string will eventually break. Sad face. Okay, and if we remove people, the string will get less tension, or there'll be less force. Okay, so it should make sense to you that the more people are hanging from a rope, it's eventually going to break. And if it's going to break, that means it's overcome force. So that is how you can answer question 2.4.1. Moving on to question 2.4.2. The velocity of the 20 kilogram block. Explain your answer. So the answer is, after much deliberation, okay, it is decrease. And we're going to think about this. So what do we know before the mass decreases? We know that F net is equal to 0 when Q is attached. Therefore, when Q breaks, okay, what will happen? We know that the force of tension will decrease, meaning that F net is no longer equal to 0, and F net is acting to the left. Okay, and the box was moving in the right. We know that the box is moving to the right, okay, and now the box is being pulled by more of a force to the left. Okay, so therefore it is decreasing. Okay, you've got to know in which direction all your forces are acting in order to answer this question. There are plenty of ways to answer question 2.4, but this is just how I like to do it. I always like to think of these questions. How does it relate to F nets equal to MA? Perfect. Thank you very much for watching. I'll see you in the next video.